There's a lot of parts to this. We got a part 4 today, and I forget, maybe there's even a part 5. No, darn, what a disappointment, there's not. There's a part 1, we'll do P2 tomorrow. But anyway, there is one problem in the lesson that we'll need our graphing calculators for. The rest of it we can probably just do by hand. So, what we're talking about today is the point of intersection. I've got just this one little definition for you, and it's a point. Not supposed to use part of the phrase in the definition, but I did it. It's a point that satisfies both equations. A point that satisfies both equations. And if you think about it on a graph, sometimes it's easier to think about these on a graph. It's basically just where the graphs touch. You could have no points of intersection. You could have one, or you could actually have more than one. Now, what we're going to do at the beginning of the lesson is we're going to be finding these points just algebraically, kind of by hand. Later on, we'll get to the graphs, but here's just kind of in general how you find, and I just kind of put POI there for point of intersection or points. To find the POI, solve the equations simultaneously. Solve the equations simultaneously. That just means at the same time. And we've had some practice with this. It's kind of like solving a system of equations. And so that's kind of the gist here, but the equations, of course, since we're up to calculus now, they'll be a little bit more complicated than they were back in algebra. But I think there's just one set of directions for the algebraic part, at least. We're going to find the point or points of intersection, and we'll show work for this part. I guess we've got 3 of these, and then one at the end where we'll use our calculators. Okie doke. Find the point or points of intersection. Show work. All right, well, first one, and we may actually do this kind of like we did back in algebra. This one shouldn't be too bad. 2x minus 3y equals 13. And then 5x plus 3y equals 1. If both of the equations are linear, so like the y's are just y, the x's are just x, no x squared or anything like that, then you can do it like we did back in algebra. There was 2 main methods that we used to solve a system of equations. We had elimination, which is probably going to be pretty nice on this one since I see those opposite terms, or substitution. Now, to do substitution, you have to solve for one of those variables first and then substitute it back in. That's not going to be real nice here with those coefficients. So, elimination, unless you have to multiply by something to get opposite terms, I would just add them up, and we're just kind of adding straight down here. 2x plus 5x is 7x. The y's cancel. And then 13 plus 1, that's 14. Well, this works out pretty nice here. Divide by 7, and you get x equals 2. So plug that back in to either equation. I think I picked the one on bottom. It'll work on either though. Plug it back in, solve it for y. So this will be 5 times 2 plus 3y equals 1. Well, 5 times 2 is 10. Subtract the 10. 1 minus 10 is -9. Divide by 3, you get -3. So the point of intersection here is at 2, -3. Those are just two lines that cross only in one spot. Okie doke. Purpose of that example is just to get us remembering some of those systems of equations and how all of that works. Let's move on to some that might be a little more complicated. Number 2, x squared plus y squared equals 25, and 2x plus y equals 10. Unfortunately, we can't do elimination here because if you go to add straight down, it's not going to work. These are squared up here, these are not squared down here, so you wouldn't really be able to add things up. So probably substitution is going to be our best bet on this problem. And looking at these equations, remember with substitution, you want to pick the easiest variable to get by itself first. Of all those terms up here, I would say this little y right here is pretty easy to get by itself. We would just need to subtract 2x. I wrote that as 10 minus 2x. You can do -2x plus 10. That's fine too. But now, here comes the substitution part. Take that expression, plug it back in wherever you see y. Okay, so this is now going to say x squared plus, it's no longer y squared, it's the entire quantity, 10 minus 2x squared, and it still equals 25. Okay, it's good to be back. I've been missing all of these different things that we do in math class. I'm going to pull this down here and then I'll erase it here in a second. When I take 10 minus 2x squared, what do I really have to do here? You can't just square the 10, square the 2x. Yeah, we're going to have to kind of FOIL this out and then plug it back in. I haven't FOILed in a long time, so here we go. 10 minus 2x, 10 minus 2x. First terms, big numbers here. 10 times 10, that'll give you 100. Outer terms, that'll be a -20x. Inner terms, well, another -20x. And then -2x times -2x, that's going to turn into a positive 4x squared. Now, I think in the PowerPoint, I just kind of left it in this order. If you'd rather put the 4x squared first and kind of do it in descending order, that's fine. But let me combine those like terms in the middle, and that's what I get for the 10 minus 2x squared. So I need to take that expression and plug it back in for the part in the blue box up at the top. Now, the nice part about this problem is that there's just a plus sign before it. So when I plug it in, I didn't even put parentheses around it. I just kind of wrote it as it was. If this had been a minus sign right there, then I'm gonna have to put that quantity in parentheses and then distribute the minus, if it had been that way. But like I said, this one's kind of nice because it's just a plus. So, oh gosh, I'm seeing the squares here, and I'm wondering if we're maybe gonna have to try and solve this by factoring. Let's get some of these like terms together. So what I did from this step to that step is really just take the x squared plus 4x squared. That gave me 5x squared. Now, if I'm going to factor that, I don't want it to equal 25. I'm going to need that to equal 0. So, subtract the 25. Anytime you solve a quadratic, it has to equal 0 first. Okay, now one more little shortcut I'm going to take here is, and it's not that I don't like yucky factoring, I don't mind it, but I think all of those terms could be divided by 5, and that will probably make our factoring a little bit easier. So even the 0, technically, I'm going to have to divide by 5. Okie doke. This looks pretty good now. So setting up my two parentheses, x times x. This is nice factoring now. Both signs are minus. If the sign on the right's a plus, they're the same. Then you look at the other sign and that tells you what they'll both be. Two negative numbers that multiply to 15 and add to -8 in no particular order because they're both negative. You want -5 and -3. Okay, if we break both of those apart, and I'll show this step, but I'm hoping we kind of remember this. If we break those apart and then solve for x, add 5, add 3, and voila, x equals 5, x equals 3. I'm almost done. I do need to write these as ordered pairs, but I know as of now that there are 2 points of intersection. One of them starts with 5, x value is 5. The other has an x value of 3. To get the y's that go with that, you can plug in the x to that equation. You could plug it into that. Probably the easiest equation to use, as long as you did all of that work correctly, is this one right here, because it has y by itself. So if I put a 5 right here for x, 2 times 5 is 10. 10 minus 10 is 0. And then putting in a 3 for x, 2 times 3 is 6. 10 minus 6, that would give us a 4. So 5, 0, and 3, 4. Those are our 2 points of intersection. All right. Again, can't do elimination here because the x's weren't the same, the y's weren't the same. Questions about number 2? Just one more of these and then we'll get our calculators out. Number 3, here we go. Y equals x squared, and then y equals x to the 4th. Well, elimination again, Not gonna work out real well, just mainly because of those x's being to different powers. So I'm gonna have to use substitution here. Now, first thing with substitution, you wanna get one of the variables by itself. You actually already have two variables, they're the same, but they're both by themselves. So that's actually already been done for you. And there's like two different ways that you could set this up. I'm gonna kind of explain both ways. Since this says y equals x squared, you could take that x squared and plug it in for y in the bottom. So it would say x squared equals x to the fourth. Or, and I think if my memory serves me correctly, I think I might have done it the other way. I took this says y equals x to the fourth. I took that and plugged it back in for y at the top. But I mean, either way is fine. It's either gonna say x to the fourth equals x squared or x squared equals x to the fourth. And that has to be true if they're both equal to y. Now, to solve that, I don't really like having the x's on different sides. So I'm actually gonna move the smaller x over to the other side. Now it says x to the fourth minus x squared equals 0. Still gotta figure out how to solve for x. And there's probably a couple different things you could do here, but if you think about factoring, that's kind of what we did on the last problem. What is always our first rule of factoring? Yeah, well, yeah, gotta pull out that common factor. So both of those, the least common factor here, or I guess it's greatest common factor, would be the x squared. So if you took, let me scoot this down here. If you took both of those divided by x squared, x to the fourth divided by x squared, that's still x squared. And then x squared divided by x squared, don't just drop it out completely and say it goes away. Anything divided by itself should be 1. Now what I did was I took that part and factored it again using the difference of squares. You don't really have to do that though. If you wanted to separate it right now and solve for x, square root both sides. There's no such thing as plus or minus 0, it's just 0. So I know 1 point starts with 0. On the other side, let's add 1 and then square root. That says x equals plus or minus 1. So there's 3 points of intersection here. One of them starts with 0, another one starts with -1, another one starts with +1. So we just have to plug these back in to find y. Plug them back in to either one of those. I'm just gonna go with the top. So 0 in for x. 0 squared is still 0. Plug in a 1 for x. 1 squared is 1. Plug in a -1 for x. Remember, a negative number to an even power is going to keep it or change it to be positive. So there are 3 points of intersection. If you did the factoring using the difference of squares, that's kind of what this work looks like up here. But Either way, should get back the same 3 points. All right. Any questions about those? All righty. Well, hopefully you've got your calculator. We're going to get that out here to help us with the last one. So I'll let you copy those directions down. Use a graphing calculator to find the point or points of intersection. Use a graphing calculator to find the point or points of intersection. Okie dokie. Let me put it up here. This is number 4. We've got y equals x to the 4th minus 2x squared plus 1. And then y equals 1 minus x squared. All right, so what we're going to do on our calculator is we're just going to type that into the first line. We'll type that one in right under it. And for this graph, you might be able to just kind of look at it and tell where it crosses. But I'm going to show you an actual thing that you can use on your calculator just to be sure that we actually have it in the right place. So I'm going to the y equals, clear out whatever you may have in there. And it really doesn't matter what order you put these in, but I'm going to start with x to the 4th power. Let me know if you have any calculator problems. Minus 2x squared plus 1. All right, next line here. This is just a 1 minus x squared. If you've never used the graphing calculator before, the x is right under the mode button. And so you've got your square over here on the left. If you need any other kind of exponent, you can use the little arrow looking button. Very good. Well, I'm going to graph this. Hit zoom 6 if your window is off. Remember, if you don't really see everything. And again, these two graphs here, it's pretty clear where they're touching, but I'm going to go ahead and show you the actual intersection program that your calculator has, and it'll just do the work for you. So follow along here with me. What I'm going to go to first is the calc option. I got to hit second trace to pull up the calc or calculate. And if you look right here, option number 5, you can just hit 5. That's the intersection. So it's going to ask you, and if you have like a TI-83, it's possible that some of the questions are different, but it should ask you 3 questions. The first question says, first curve, question mark. Now, what we need to do here is we need to make sure which curve our cursor is on. Right now, I can't really tell if it's on the blue one or the red one. So I'm just going to hit the left arrow here to kind of bring it over. And okay, I can see clearly now that it is on the blue graph. Your calculator might not be blue, but it's on the one that's on top. So I'm going to hit enter. I'm calling that my first curve. Now it should ask you for the second curve. You need to make sure that your cursor is on the other graph now. Mine kind of brought it down there for me already, but you can hit the arrows if you need to move it around. It can be anywhere, just as long as it's on the other one. I'll hit enter again. Now it says guess. So, I mean, it's kind of looking like it crosses in 3 places. And again, I know this one's kind of obvious, so you can probably already write the ordered pair. But for the guess, just put your cursor as close to the point as you can, whichever one you're trying to find. I'm gonna go for the one on the left. So enter, and it tells you exactly what the ordered pair is. So we could kind of already tell it's at -1, 0. I'm gonna make a list over here. These are our answers, basically. Now I'm gonna do the process all over again for the point of intersection in the middle. If you're not really seeing it very well, you can zoom in. So like zoom, option 2, wherever your cursor is, that's where it's gonna zoom. I may just scoot that, there we go. I may scoot that over a little so it zooms right for the center. So that does make it quite a bit more clear, but I'm pretending like these are not nice points and that I need my calculator to help me. So let me just try the next one here. I'm gonna try to see if it can tell me what that point is, where they intersect. So you can start it all over again. Second trace, option 5, first curve, I don't know where it's at right now, so let me scoot it down. It's on the blue one. Sure, that's my first curve. Second curve, yep. So guess, I'm gonna bring it back to where it was, and there we have it, 0, 1. That's the second one. The third one is at 1, 0. Again, it's clear on this graph, but if it's ever not clear, I guess, the calculate and then the intersect button can tell you exactly where those are at. All right, that's our last example. So I may go ahead and, I didn't really list all of them over here, but it was -1, 0, 0, 1, 1, 0. Those are our 3 points of intersection. So let's go ahead and start on C4. If there was any trouble with calculators, now would be a good time to ask. You do have a little over 15 minutes left. Page 10, we've got 39, 41, 45, 57 to 60, 62 to 62 and 63. I put don't graph on there. I may, once you open your books up here, I may kind of make sure that you understand the directions. If the directions say to graph though, we're gonna skip that part.